I prefer to have questions that cannot be answered than answers that cannot be questioned. This quote from Richard Feynman summarizes the spirit of modern physics. There is a secret that scientists keep in the corridors of universities. We have the formulas, we have the results, and we have the technology that works. But nobody knows why science acknowledges the rules but accepts the mystery without understanding the logic behind it. Today, we'll explore the three pillars of what physics accepts as absolute truth, but admits it is unable to explain. Prepare to discover that the universe is a mathematical miracle that defies our logic every second. Richard Feynman was a man who wasn't impressed by titles or authority, but there was something that genuinely disturbed him, almost to the point of scientific reverence. The existence of certain numbers in nature that simply, they are what they are. In physics, we call these numbers universal constants. They are the invisible pillars upon which the entire edifice of reality is built. Science acknowledges these values with precision to many decimal places, but almost no one talks about the embarrassing fact that we have absolutely no idea where they came from. Why is the speed of light exactly 299,792,458 meters per second? Why isn't it double? Why isn't it half? Feynman said that these numbers seem to have fallen from the sky without any instruction manual, and the passive acceptance of these values is the greatest unsolved mystery of modern science. Imagine you enter a control room that manages the entire workings of the universe. There, you find a panel with about 20 buttons or potentiometers. Each button represents a fundamental physical constant: the force of gravity, g-du, the mass of the electron, m-e-du, Planck's constant, h2, and the force that holds the atom's nucleus together. Science admits that these knobs are set to specific, immutable positions. What's frightening, and what Feynman insisted on, is that this adjustment is unimaginably precise. If you moved the gravity knob just 1 millimeter to the right, the universe would collapse upon itself within seconds of the Big Bang. If you moved the strong nuclear force knob slightly to the left, atoms would never form, and the universe would be nothing but a lonely soup of hydrogen. We live in a universe that seems to have been tuned for existence, but physics admits it doesn't know who or what did the tuning. We accept the numbers because they work, but the why of their precision is shrouded in an abyss of silence in mainstream science. Within this mystery of constants, there is one that haunted Feynman more than any other: the fine structure constant, represented by the Greek letter alpha, salfado. Its value is approximately $1,137. Feynman wrote that this number is one of the greatest cursed mysteries of physics, a magic number that comes to us without man understanding it. He described this number as if it were written by the hand of God, and said that all good theoretical physicists should put a plaque on their walls with this number to remind them of their profound ignorance. In why $137? This number determines the force with which light interacts with matter, electrons. It has no units. It is not measured in meters, kilograms, or seconds. It is a pure number, a fundamental ratio. Science acknowledges that it is essential for DNA to hold together and for stars to produce carbon, the basis of life. However, if you ask a physicist why the value is $137 and not $140, the answer will be an honest and dry, "We don't know." And we accept the number because without it, Feynman's quantum electrodynamics fails completely. But its origin remains hidden in the inaccessible source code of the universe. The acceptance of these constants reveals a profound tension in science. On the one hand, we want to explain everything through causes and effects. On the other hand, the constants seem to be causes without causes. They are the raw data of existence. Feynman challenged the idea that science has fully explained the universe as long as these numbers remain unexplained. For him, accepting that gravity has a specific value without understanding why is like saying we understand a symphony simply because we know the frequency of the notes, without knowing the composer or the original score. Physics admits constants as boundary conditions. That is, we accept that the playing field is like this. But Feynman saw in them proof that our understanding of reality is merely superficial. We are describing the symptoms of reality, but not its internal logic. Almost no one talks about how science, at its deepest level, is dependent on numerical dogmas that we accept out of pure mathematical necessity. To try and explain why these numbers are so perfect for life, some modern scientists turn to the idea of the multiverse. They suggest that there are infinite universes, each with its own randomly adjusted buttons. We would be in the prize universe where the numbers allow our existence, the so-called anthropic principle. Feynman, with his pragmatic skepticism, would probably look at this with suspicion. For him, resorting to infinite invisible universes to explain the mystery of this one seemed like a way of avoiding admitting that there is something fundamental that we still don't understand. Science acknowledges the constants needed to keep the equations functioning, but the escape to the multiverse only pushes the mystery under the rug. The physicist's responsibility, in Feynman's view, is to confront the number $137 and admit, there's a logic here that I'm not yet able to read. The true value of understanding the mystery of constants lies in awakening a form of cosmic humility. It's not about religion, but about a profound sense of wonder in the face of the absurd. Science acknowledges that the universe is a mathematical construct of almost unbearable elegance. Feynman taught us that the greatest intelligence is not that which claims to know everything, but that which recognizes the limits of its own knowledge. The constants that fell from the sky are constant reminders that the universe owes us no explanations. It functions with clockwork precision, but its internal gears are made of numbers that defy our most basic logic. Accepting what we don't understand is not a defeat for science. It is the act of intellectual honesty that allows the search to continue. As Feynman showed, mystery is not what prevents us from moving forward. It is what invites us to continue looking at the stars with the curiosity of a child. Richard Feynman used to say that nature is not just strange, it is absurd. The second pillar of this roadmap delves into the heart of quantum mechanics, wave-particle duality. Almost no one talks about it with Feynman's brutal honesty, but science admits that the foundation of reality is a logical contradiction that no human brain can fully visualize or accept. We accept that light and matter are two mutually exclusive things at the same time. For common sense, this is impossible. For Feynman's physics, it's simply how the universe behaves. And if you don't like it, that's your problem and your limited intuition. Science acknowledges that depending on how you look at it, an electron behaves like a particle, a small ball of matter with a fixed location, or as athen, a disturbance spread through space, like sound or a wave in the sea. The monumental problem is that, in our classical logic, nothing can be both things simultaneously. Imagine you have a friend who's like a cat in the kitchen and like a dog in the living room, but he's never in between. Feynman used the experiment of double slot to illustrate this insult to reason. Consider this. If you fire electrons at a barrier with two holes, they pass through both simultaneously, interfering with each other as if they were water waves. But if you place a detector to see which hole the electron passed through, it instantly decides to be a particle and passes through only one. Science admits that nature changes its identity depending on the question we ask it. We accept this because experiments confirm it, but Feynman confessed, nobody understands the internal mechanics of it. We simply accept the schizophrenia of matter. Feynman was the physicist who best embraced pragmatism in the face of absurdity. He realized that our intuition evolved to hunt animals and gather fruit on the savannah, where things are solid and predictable. Our brain was not designed to understand the atomic world. Therefore, science acknowledges duality, but abandons the attempt to explain it through human metaphors. Feynman created the quantum electrodynamics, QED, to describe this duality not through mental images, but through probability calculations. He stopped trying to imagine the electron and began to treat it as an entity that follows mathematical rules that have no translation into Portuguese or any spoken language. Accepting meaningless duality means admitting that reality is not obligated to be comprehensible to humans. Physics admits that truth is paradoxical. Feynman taught us that scientific maturity begins when we stop demanding that the universe be logical, according to our limited standards. Feynman had a special fascination with light. He explained that a photon travels as a wave, exploring all possible paths, but reaches its target as a particle, a discrete packet of energy. Almost no one talks about the fact that light has no mass, does not experience time, and behaves like an oscillation in a vacuum, yet it can still push against solid matter. Science acknowledges that light is the bridge between the purely energetic wave and the purely material particle. Feynman showed that if we try to force light to be only one of these things, all of modern physics breaks down. We are forced to accept duality for lasers, computer transistors, and solar panels to function. All our technology rests on a phenomenon that physicists admit is madness. This senseless duality leads us to a disturbing conclusion about the solidity of our own bodies. If matter is both wave and particle at the same time, it doesn't have a fixed form until something interacts with it. Feynman described the atom not as a miniature solar system, that classic textbook image, but as a probability cloud. This means that, before being observed, matter is in a state of indecision. It is a wave of scattered possibilities. Science admits that the solidity we feel when touching a table is merely the result of trillions of these clouds collapsing into particles in a fraction of a second due to interaction. Almost no one mentions that the basis of matter is something immaterial and wave-like. Feynman accepted this with an almost childlike honesty, marveling at the fact that the world is built on such unstable and bizarre foundations. Duality is not a miscalculation. It is the signature of a universe that is infinitely more creative and strange than our logic allows. The closing of this topic is an invitation to humility. Richard Feynman believed that wave-particle duality was nature's most profound lesson. The truth can have two contradictory faces, and both can be equally true. Accepting what doesn't make sense is the pinnacle of human intelligence in Feynman's view. Science acknowledges that light is both wave and particle, just as life is both chemistry and poetry. He encourages us not to fear paradox. When we stop trying to force the universe into our mental boxes of this or that, we open space for true discovery. This senseless duality proves that reality is a magic show where the trick is never revealed. And physicists, like Feynman, are the spectators who have learned to appreciate the magic without needing to know where the rabbit was hiding. Richard Feynman changed the history of physics by embracing a truth that even Albert Einstein tried to deny until his last breath. The universe, at its most fundamental level, has no certainties. It only has chances. Almost no one talks about this with the necessary clarity, but science admits that the law of cause and effect, the idea that if you know the present, you can predict the future with precision, is an illusion that only works on our human scale. In the world of atoms, the will of nature is purely probabilistic. Feynman not only accepted that the universe plays dice, he taught us to calculate the stakes of a game whose origins are unknown. Before the quantum revolution that Feynman helped lead, scientists believed in a clockwork universe. The idea was simple. If we had a powerful enough computer and knew the position and speed of every particle in the Big Bang, we could predict everything that would happen today, from the fall of a leaf to your last thought. It was absolute determinism. Feynman helped bury that idea forever. Science now admits that if you isolate a single radioactive atom, it is physically impossible to say when it will decay. There is no hidden variable, no hidden timer inside the nucleus. The atom could decay in a second or in 1 billion years. There is no mechanical cause that determines the exact moment of the event. There is only a probability. Feynman showed that nature is inherently uncertain. Accepting this was the greatest intellectual challenge of the 20th century, for it means admitting that the foundation of reality is not the solid steel of immutable laws, but the unstable fog of statistics. The universe is not a straight line. It is a tree with infinite branches where chance is the gardener. The path integral, where everything happens simultaneously. Feynman's most brilliant contribution to understanding this probabilistic nature was his sum of stories, or integral of paths. Almost no one explains this directly, but science admits something disturbing. For a particle to move from point A to point B, it doesn't choose a single path. It travels all the possible paths simultaneously. Imagine you want to go from home to work. In Feynman physics, you don't just go down the main road. One version of you goes by Mars, another version goes around the moon, and another crosses the center of the Earth. Each of these paths has a probability range. When you add all these probabilities, most cancel each other out through interference, and what remains is the path we call classical reality. In nature is a gambler, betting on all the horses in a race at the same time to ensure that the final result follows the laws of physics. We accept that the path we see is merely the result of an immense competition of chances. We live in the average of infinite absurdities that occur in the quantum underworld. Feynman's honesty. Nobody understands, and that's okay. Many scientists try to give quantum probability a philosophical or mystical meaning to make it palatable. Feynman, however, was brutally honest. We don't know how nature chooses the final outcome among so many probabilities. Physics admits that when we make a measurement, the cloud of chances collapses into a single real event. But how does this collapse happen? Why this outcome and not that one? Feynman's answer was a sincere, "We don't know." He said that science stopped trying to explain the inner workings of the system and started describing its statistical behavior. We accept that the universe is a game of chance because, when we play according to Feynman's probabilistic rules, our technology works perfectly. Your smartphone only exists because engineers accept that electrons have a probability. It's about crossing a solid barrier, tunneling effect, not a certainty. Almost no one talks about how the foundation of the digital age rests on a principle that physicists admit is incomprehensible to human logic. We don't understand the workings of the universe. We've only learned to count the cards with absurd mathematical precision. Uncertainty as the only true freedom. There is a hidden beauty in the probabilistic nature that Feynman often suggested in his lectures. If the universe were perfectly deterministic, like a film already recorded on a DVD, we would be mere spectators without any power of influence. The future would simply be the unfolding of a pre-written tape. But in a universe of probability, the future is always open. Science admits that tomorrow is not set in stone. Every observation we make, every interaction we have, is a new roll of the dice that helps define the next stage of reality. Feynman showed us that uncertainty is not a flaw of our ignorance, but a fundamental and necessary property of nature. The universe doesn't know what will happen next until the event occurs. This acceptance of chance transforms our worldview. We stop seeking guarantees and start seeking possibilities. The probabilistic nature is what allows for novelty, evolution, and surprise in a cosmos that would otherwise be a cold, repetitive, and soulless machine. Climax: the statistical miracle we call life. The conclusion of this topic touches on the open wound that Feynman loved to poke at. Accepting the probabilistic nature of events is accepting a miracle without the need for a miracle worker. It is accepting that there is a perfect mathematical order, the laws of probability, that governs absolute and unpredictable chaos, individual quantum events. Science acknowledges that chance is king, but a king who follows rules of impeccable elegance. Almost no one talks about this because it's difficult for the human ego to accept that we don't have total control and that causality is a simplification for minds that can't tolerate uncertainty. For Feynman, however, this was the greatest adventure of all. To be a conscious observer in a universe that reinvents itself every millisecond, in every tiny probability that, against all odds, decides to become real. In the end, physics admits, we don't know why the die lands on a specific number, but we are grateful that it keeps spinning. Richard Feynman didn't want us to just be knowledgeable about physics. He wanted us to be honest about what science actually knows. We saw that the constants, these are magic numbers that we accept without knowing their origin. We saw that duality, it's a contradiction that we accept because it works in the laboratory. And we saw that the probability, it is the essence of a universe that refuses to be predictable. Science acknowledges all of this, but almost no one talks about it. Because these truths require you to abandon the arrogance of thinking that the universe owes explanations to our logic. Feynman taught us that knowledge doesn't kill the mystery. It feeds it. Reality depends on you to be observed, but it will never cease to be strange, uncertain, and wonderful. As Feynman would say with a smile, nature isn't classical, damn it, and if you want to understand the world, you'd better accept its madness. What will you choose to observe today?